Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Marissa and I will be presenting our Geotechnics group project by Group 1. Okay, so this is our group members. So firstly, this is ELVIS, this is YEONG, this is IMAN HAIQAL, this is Tay, this is NURFATINI, and this is me, Nur Marissa. Okay, so this is the table of contents of throughout our presentation for our project. Okay, so we will start with our company background, which is our project title is Geotechnical Investigations and Foundation Design for the Proposed Interchange Bridge over Taman Bukit Tropika, Ulu Tiram, Johor. And this project is organized by FME LIT Construction Sendirian Berhad. So here are some of our scope of work, which is for the first one, it is a subsurface analysis, detail review, load evaluation, comparative design, settlement constraints, and stability analysis. Okay, so next, move forward to the design project. So for our project title, it is Geotechnical Investigation and Foundation Design for the Proposed Interchange Bridge over Taman Bukit Tropika, Ulu Tiram, Johor. Our project is organized by company named FME LIT Construction Sendirian Berhad. And our project also managed by our CEO, which is Tay Junxiang. Okay, so here are the list of person in charge for every each sub project. Okay, so for the site investigation, it is managed by Ms. Nurfatini. For the retaining wall part, it is managed by Mr. LIEW. For the shallow foundation, it is managed by Mr. Muhammad Iman Haikal. And lastly, for the pile foundation, it is managed by me, Ms. Nur Marissa, and Mr. ELVIS.
The site investigation, soil exploration, or site inquiry refers to the field and laboratory investigation needed to get data. This details examining the site's currents, records, documents, and data. So geological maps and any information on past land use are examples of this. Physical examination of the location are record current circumstances, vegetation, and any obvious indication of the possible problems. So this stage as in recognizing certain areas of concern and comprehending the context of the location. This component centers on the site's underneath circumstances to figure out the geotechnical qualities, laboratory testing, analysis, and soil and rock samples are required. For slope stability analysis, foundation design, and other structural issues, this knowledge is essential. Here is some of the objectives for doing site investigation, which is assess the site's suitability for the purpose used to see environmental issues, topography, geology, and soil condition. Next, to determine any possible dangers or difficulties the location may present, such as contaminated soil, geological hazards, flooding, or unstable soil. And the third one is to help with the construction of suitable foundation for the structures and to find out about the subsurface characteristics on the site. And the last one is to determine how the proposed development will affect the environment and what steps should be taken to reduce any negative effects. Okay, next for the project introduction, the design proposal is to design the foundation of a column with a 6.5 meter height clearance to support the proposed interchange bridge. So two borehole locks designed as borehole 2 and borehole 3 are situated in close proximity to the proposed interchange bridge, columns, and retaining structures. So these locks are spaced 30 meters apart, and the type of boring used was the rotary wash beam method. And the groundwater table is located at 2 meters below ground surface. And we can see for determination depth, for borehole 2 is 37.5 and for borehole 3 is 33.19. So next for the groundwater table, for borehole 2 is 5.20 meter and for borehole 3 is 3.50 meter. And the type for both borehole 2 and borehole 3 is rotary.
Soil profile for our proposed interchange bridge is based on the provided borehole lock 2 and borehole lock 3. Both boreholes are near the columns or retaining structure 30 meter apart. Termination depth for borehole 2 is 37.5 meter, while termination depth for borehole 3 is 33.19 meter. Groundwater table for borehole 2 is around 5.2 meter and borehole 3 is 3.2 meter, as we can see at our soil profile. The purpose of a borehole log is to provide a detailed description of the soil or rock layers encountered at various depths. From the top soil to the end of termination depth, the description of soil will change at a certain level of depth. While the soil weathers and organic matter decompose, the profile of the soil change. For example, a highly weathered, infertile soil usually contains a light colored layer in the subsurface soil from which nutrients have leached away. Based on our soil profile, the topsoil gives us very loose sandy seed until the depth of 9 meter. It becomes a medium density sand. Below 15 meter, soil profile more into hard and very dense soil. On the other hand, a highly fertile soil frequently has a deep surface layer rich in organic materials. We may begin to estimate how a soil will function under specific nutrient management setting based on the indication offered.
Thank you, Iman. And I'm Chi. Now I will talk about the retaining wall design. So this is our retaining wall design. The drawing is based on the scale of 1 to 10. Then we just have only one layer of soil, which is the silt. But the groundwater table is at sit at 3.5 meters, so we need to consider two types of gamma value in our calculation. Then there are horizontal force acting to the retaining wall, which is the passive force at existing soil and active force at backfill soil. These are the formulas that we are using in our calculation of the retaining wall. This is our design parameter and soil properties for our retaining wall. The height of the clearance is 0.5 meter and the retaining wall height is 7.5 meter. The variable load, which is a surcharge, is acting on the retaining wall, which is 20 kilonewton over meter square. The soil parameter, as before, we just only have one layer of soil. But they are existing of groundwater table at 3.5 meters, so we need to consider 2 gamma in our soil parameter for backfill, but only 1 gamma for our existing only. So our first calculation is overturning of the over design factor. Then we use the MSEA method to calculate it. So we got two combinations here, which is combination 1 and combination 2. And we need to calculate the active earth pressure, for permanent and variable unvariable load. Then we need to also calculate the moment arm and also the passive earth and passive force. Then we build a table to calculate the total moment of the retaining wall. Then we use the formula to determine the over design factor. So here we can see that the combination 1 is more critical than combination 2 since the over design factor is for combination 1 is lower than combination 2. For sighting, we also consider two combination, which is combination 1 and combination 2 also. So we get the RVD from the previous table. Then we with the design soil parameter, and we assume the delta is 2 over 3 of V design. Then the setting for combination 1 is lower than setting for combination 2. It means that the combination 1 will be more critical than combination 2. The last part of our calculation for the retaining wall is bearing system. Since there are horizontal load acting on the wall, then we need to calculate the eccentricity in the B direction with the formula. Then we need to calculate the B prime also. After that, we use a MSEA method to calculate the over design factor. So there are combination 1 and combination 2. Then we get the design parameter to find the bearing resistance. Then inclination of base of foundation, shape of foundation, and inclination of load we find by using a formula. And since there are exceed the groundwater table at 3.5 meters, so we need to consider the effect of groundwater table, which is will change the Q term and gamma term in bearing resistance. Then we need to calculate the contact pressure to get the over design factor by using formula. Since the over design factor is smaller than combination 1, which means the combination 2 have more critical than combination 1. Then I will pass to Jun Sang to continue the presentation. Thank you.
Thanks, Yongqi. I am Jian and I am going to talk about the shallow foundation design. In the shallow foundation design, we first need to determine the minimum width of footing B to ensure that our shallow foundation design is accepted. Firstly, we need to do some assumptions such as width and length of footing, depth of footing, thickness of footing, unit weight of footing, safety factor, location of groundwater table for ground surface, unit weight of water. Next, for our soil profile and value of SPTN, we can determine the soil parameters of sandy slip by using a SPTN method. We can know the unit weight, saturated unit weight, cohesion, internal friction angle of sandy slip. By using the internal friction angle, we can also know the bearing capacity factors. Next, the question is given vertical load of 8,000 kN and horizontal load of 400 kN. Thus, the design load is square root of 8,000 power of 2 plus 400 power of 2. The groundwater table will influence the stress at base and unit weight of soil. In our project, it is case 2, which is groundwater table at the footing level. Due to the soil information is not sufficient to design the shallow foundation, thus we only can apply the ZHANG ultimate bearing capacity equation to determine the minimum weight of footing B. The minimum weight of footing is 3.52 meter. Thus, we use the weight of footing is 8 meter. Now we can go into design the shallow foundation with the weight of footing is 8 meter. The assumption remain unchanged and enter the value of B. The soil parameter of sandy silt also is same and total design load also remain constant. By sub into B value, we can know the stress at base is 44.8 kN per meter square and the unit weight of sandy silt is 8.7 kN per meter square under the influence of groundwater table. By applying the Tataki ultimate bearing capacity equation, we can know the ultimate bearing capacity and then calculate the net allowable load. The calculated net allowable load is more than total design load, thus the design can be accepted. Now we can check the settlement. From the table, we can know the modulus of elasticity and the position ratio of sandy silt. The net pressure from footing is vertical load divided by the area of footing. Thus, the calculated settlement is 30.33 mm and the maximum settlement is 50 mm. Thus, the design can be accepted. The weight of footing B is 8 meter. However, in the reality, the 8 meter weight of footing is costly and not logical in the construction of shallow foundation. Thus, the pile foundation should be applied for this case. Therefore, I will pass to Elvis to explain about the pile foundation design.
Thank you, Jinsang. So now I'm going to present about our company pile foundation design, which are single pile and group pile. Borehole 3 is chosen for the pile foundation design because borehole 3 is highly saturated with water compared to borehole 2. For single pile, a diameter of 0.5 meter and length of 25.5 meter pile is used and assumptions are met. Next, we calculate the pile capacity based on the SPTN and we get Q allowable S plus B of 1731.683 kilonewton and Q allowable of 1908.813 kilonewton. We choose the smaller value between the Q allowable S plus B and Q allowable. Hence, we choose the Q allowable S plus B as our allowable compressive load capacity of the single pile. However, the value of the allowable compressive load is smaller than the maximum compressive load, which is 8,000 kilonewton. Thus, the design of the single pile is rejected. Since the single pile foundation design is rejected, the group pile foundation is recommended to be constructed. We redesign our pile to 0.8 meter diameter and 22.5 length, and the assumptions are met as well. Then we start our calculation for the pile capacity based on SPTN. Since we assume 4 pile for one leg, the allowable load and overall allowable load is multiplied by 4 as well as the uplift capacity of the pile. Finally, we get the Q allowable S plus B for 4 pile is 9,339.269 kilonewton and the Q allowable is 10,487.615 kilonewton. Same as the single pile, we will choose the smaller value between the Q allowable S plus B and Q allowable as our allowable compressive load of the pile. Since the value of allowable compressive load of pile is larger than the value of 8,000 kilonewton, the design for the group pile foundation is accepted. Since the group pile is accepted, we start to calculate the eccentricity of the pile foundation. Table at the top left of the slide is the data of the group pile. And after the calculation, we get the eccentricity of the pile is 0.275 meter. Finally, we calculate the QM of the pile of each pile, and we get the values of QM are 1,714.286 kilonewton for pile 1 and 2, and 2,285.714 kilonewton for pile 3 and 4. Since all the value of QMs for the pile are smaller than the allowable load for each pile, the design of the pile is accepted as each pile is able to carry the applied load. In conclusion, site investigation provides available sound information for the proposed site to design the retaining wall, shallow foundation, and pile foundation. For retaining wall design, we need to design the wall using both combinations to avoid overturning, sliding, and bearing. For shallow foundation, the 8 meter width of footing is accepted but costly and not logical. As for pile foundation, the single pile foundation is rejected and the group pile foundation can be accepted due to the allowable compressive load capacity. As a future engineer, we have to consider all important aspects in retaining wall and foundation design. That's all for our presentation. Thank you and goodbye.